Well, good evening to everyone. Our speaker this evening is Dr. Ryan Walker, who is a lecturer and researcher with the University of Oxford. He has a background in automotive and aerospace engineering with a history of working in the motorsports sector. Prior to joining the university, he spent 9 years as a systems engineer with the Mercedes Formula One team, and he has in the past worked in a wide range of categories of motorsport. He's the faculty advisor for the Formula student team at the University of Oxford and also pursues his research interests in advanced thermofluids and condition monitoring in the automotive sector. So, over to you, Ryan.
Thank you very much. Good evening, everyone. Just share my screen. Great. Just to check you've got that okay?
Yep.
Fantastic. Okay. Thank you very much for having me this evening. Thanks for the introduction. I'll start with a little bit more about myself, but I'm going to talk primarily this evening about Oxford and Oxford Formula Student. It's quite a new thing for us and for myself in a way. I'm aware that this being the IMechE, we'll have some members online. I think you've already seen a few familiar names who will be extremely well versed in what Formula Student is, and perhaps some of you who aren't. So I'll try and cover a little bit of both sides of that, but please do ask questions at the end. So let's get started. I've got a little bit about me. I won't go on about this too long, but as Brian kind of introduced, so I studied automotive engineering at Leeds University, essentially mechanical engineering. I dreamed of sort of being a motorsport engineer, I guess, a Formula One engineer, as a lot of people did back then. And at the time, Leeds was a university that was doing well in Formula students. They were quite well versed in it, which is one of my deciding factors for choosing the university. I graduated from that and then started working in motorsport, worked my way around over the years, doing a lot of sports car racing. I did the Le Mans 24 hours with Lotus, the picture down there. Worked with Formula 2 as it was with Palmer Sport for quite a while, looking after all of the cars on the grid at a time when they were all identical chassis and rotated engineers. Then it was run out of Bedford. There's a bit of GT racing down there. Sort of a bit of a freelancer, and for those of you who are familiar with the motorsport world, it's not always the most reliable. So after a number of teams going bust and struggling a little bit for consistent work, I went back to university. I went to Cranfield and did a doctorate in aerospace engineering with Rolls-Royce. Continued working on this. Bit of a background on my driving exploits. So I'm by no means a racing driver, and it was apparent very early that I was not going to be, so took it in a slightly different route. I have a history of driving unsuitable vehicles to far-flung parts of the world, starting when I was at university. So you have an ice cream van on its way from London to Mongolia in the top left of the screen there. My trusty Ford Granada, which drove to Afghanistan in 2008 for charity. I have the ambulance that went from California to Honduras, part of this program in repurposing ambulances for use in other countries, and my little Fiat Punto somewhere in the Arctic in winter back there. And then, yes, as mentioned, so after my doctorate, I took up a position at Mercedes. I was there for 9 years as a systems and then subsequently senior systems engineer, which is a bit of a vague term in Mercedes speak. It sort of encompassed a lot of simulation, a lot of support for all of the different design groups within the design office there. A lot of work on things like cooling systems, fuel systems, hydraulics, a bit of brakes and suspension, and quite varied work, which was quite nice and a little bit unusual in Formula One world. Obviously, we had quite a lot of success. For those of you that know Formula One over that time, there's a run of 8 consecutive World Championship winning cars, and a bit of a gratuitous picture there with some trophies from 2014. had the opportunity to do a few other bits and pieces along the way, a bit of consultancy. So Mercedes are still involved with the America's Cup yacht. If you're not familiar with those, I do suggest you check them out. It's fantastic pieces of engineering with the foiling. That's the Ineos Grenadier road car, which I was involved in the 4x4 system for. So that's that. And in last April, I left Mercedes and I've taken up a position back in academia. I am, as mentioned, a departmental lecturer responsible for Oxford University Formula Student. So I won't go too deep into the background of Formula Student, because I'm sure some of you are aware, especially as it's an IMechE event. But just to cover a little bit, it started in the USA in 1981 as Formula SAE. I understand 4 teams competed. I think I might be wrong, but the University of Texas might have won that inaugural event. Back when I did Formula Student or Formula SAE, Leeds actually took the car all the way out to America to compete. But the IMechE have started a Formula Student in the UK as of 1999. So still been going a good, the 25th anniversary, I think. Fantastic event. Essentially, the students design, build, test, and ultimately race small single-seater vehicles. It's now spread into this franchise almost, where it's spread all around the world. There's a Formula SAE in Australasia, in Germany, multiple events in America, obviously the Formula Student event in the UK. And these days it was started as a combustion event. That's still very much a big part of it, where teams can use typically a motorbike or quad bike engine, 700cc. You can use sustainable fuels and whatnot these days in it as part of the competition. But it's also evolved over the years, and so now there is an electric category, which is what I'm primarily going to be talking about. It says Oxford competes in, and also relatively recently an AI for driverless cars, which is quite fascinating, and hopefully something that Oxford will get involved in the not too distant future. The event in the UK is at Silverstone in the summer. Last year it attracted something like 120 teams, I think, from all over the world. Obviously a lot of English teams do take part in that, but they come from all sorts of far-flung places, and yeah, there's some really great competitions, and it is really a truly international thing. So for Oxford, it's a relatively new thing. Being new there myself, having started last April, I can't say as to the history of why they haven't necessarily got involved extensively previously, but 3 or 4 years ago, some of the students at Oxford got together and decided off their own back they were going to put a car together and enter the competition. There were enough people interested in automotive or just the program as a whole. And so they started designing the car, managed to convince the faculty to give them some support for it, managed to bring in a bit of sponsorship, and spent some time building and competing the car. Went in for the first time into the competition last year in 2022. So although it's one of the oldest universities in the world, we're one of the newest when it comes to Formula Students, but it's been a steep learning curve, and I'll go into some of that for the students, but I think it's being taken seriously within the university. It's a fantastic opportunity, and so looking forward to building on it as the years go by. But nicked off the IMechE website up in the corner there, there's a sort of, I think they call it winners circle of the top teams in the UK. So our friends down at Oxford Brookes are particularly successful. There are some very strong teams from Germany, Stuttgart and the Technical University of Munich produce fantastic cars. I've got the picture there of what a Formula Student car can look like in to several years of development with carbon fiber, 4-wheel drive, all of these things which Oxford don't have yet, which I'll go into a little bit. And at Oxford, as I understand at most universities, it's a largely extracurricular activity. So the engineering science degree at Oxford is 4 years. It starts with general engineering and then spreads out when they have a choice in the 3rd and 4th year of various modules. And only since I've come on board have they started to integrate some of the Formula Student into the course. It's a student-led activity, so I'm there as faculty advisor to help act as a liaison with the faculty and with the university. But for obvious reasons, I'm not allowed to design the car for them or get involved in it. And the same with the rest of the faculty. It has to be student-led from top down. I'll talk a little about the structure of it in a bit. And yeah, I whipped through, again, some of you will be familiar with this, but for those who aren't, the competition itself takes place in the summer, typically at Silverstone Circuit, although I should say, whilst it's at Silverstone Circuit, it's not around the Grand Prix circuit itself. They set up a short form racetrack is created using cones and somewhat in the area of Silverstone, but it's a fantastic place for the students to be able to go and drink in the atmosphere of a proper racing event. It's split into what they call static and dynamic events. The static events, this has evolved over the years, especially since I did it an embarrassingly long time ago. This is a fantastic and I think often overlooked from the student's point of view part of it. So there's a design exam, cost report, really detailed cost report. These days, a sustainability aspect to it as well. Business presentation, we were just talking about at the beginning, for those who caught that. The technical and safety scrutineering, which is a huge part of Formula SA and a huge challenge. Again, I'll go into that in a little bit more detail. And that sort of includes a tilt test and a brake and noise test. The dynamic events, which are the ones which, it's fair to say, attract most of the students' interest, are skid pads, so a figure of 8, sprint race, so a single lap or more around the short race around short circuit that's been set up. Acceleration, so a drag race or a drag strip. Endurance, which is I think a 22-kilometer, if I'm not mistaken, roughly 20 minutes or 22 lap of this little circuit that's been set up for them, and not applicable for the electric cars, but there's a fuel economy side. Right. And you can see the points down there on the side, which I think is a really interesting way that the competition has been set up. My experience is that the students at Oxford are minded to look at the endurance, and there's 250 points that are available, and focus very much on that, sometimes at the detriment of things like the business plan, the costs of manufacturing and engineering design. But of course, when they go out in industry, then the business plan, cost of manufacturing, engineering design, all of these are huge parts of what they're going to be doing day to day. And so part of what I've been doing at Oxford is really trying to focus the minds that these bits are as important as getting the car ready for the endurance event. I'd also say that the competition in 2022 had a high attrition rate, as it often does with cars that are designed by students. So don't quote me exactly, but I think in the electric vehicle class there was something like 50 or 60 entrants to it. I think something like 4 or 5 managed to pass the scrutineering in time to take part in the endurance race, and 1 electric vehicle, to my knowledge, possibly 2, managed to complete the endurance event. So it's an extremely high attrition event, which I think leads on to some of the design parameters that the students need to be aware of, and also focuses the minds on that performing well can significantly rest on their performance in things like the business plan presentation, cost and manufacturing, and engineering design. So apologies, this might not work. I know over Teams it's a little bit tricky. I've blatantly robbed this from the Formula Student website. I'm going to press play here. If it doesn't work or there's any problems, I do advise you to just have a quick look at the IMechE website when you have time. Just have a quick look at some of the videos they've got there. It's only a couple of minutes, but gives a good introduction and background to the 2022 event. hopefully that wasn't a complete disaster and you caught some of that. Right, so rules. This I'll keep very brief, but it's been interesting to me coming back to Formula Student how much the rules have evolved over the years. There's currently 154 pages of rules for Formula Student, and I think just having a quick glance at the technical regulations for Formula One, it's 179 pages, so it's really not that far off these days, the amount of things that have been included. And I guess over the years, much in some parallels like Formula One, as the various universities have pushed the envelope of the rules in various ways, there have been clarifications and bits and pieces. I think Oxford actually prompted a couple ourselves the last year that have been introduced to it, so it's an ever evolving thing, and it's really interesting to see how it's come on. A large part of it is obviously dictated towards safety, with students designing and building and ultimately racing what is a fairly quick car, geared generally towards acceleration. So I should say that top speeds are generally pretty low. I think Oxford's is geared to a maximum of 60 kilometers an hour or thereabouts. But equally, I think the world record has just been broken for 0 to 60 acceleration times by a Formula Student team of about 1.4 seconds or something like that. So with that kind of performance, obviously safety rules are critical. Just pulled a couple of examples up here. So we've got things like the roll hoop for clearances in case of rollover, Percy, so the angle of the driver, 95th percentile in relation to where they are in the cockpit, clearance areas. So there's also things like a jump out test to make sure that the driver can get out of the car sufficiently quickly in the case of an incident. This is a template for the cockpit to check there's enough clearance down by the students' legs and so on and so forth. And they really are quite detailed, and ensuring that you build a car to the regulations is a massive part of it. The scrutineers and the scrutineering process, I mentioned before some of the stats about how many teams have managed to get through scrutineering. The IMechE and the people who volunteer their time to do that are extremely supportive, and it's very much a helpful environment, and everyone's keen to see the students get their cars legal and race in the event. But at the end of the day, if they don't meet the rules, then they won't be allowed to. A few more things, obviously, again, mentioning safety. There's things like a frontal impact zone and impact attenuator, which is predefined side impact areas, obviously prepping for all the potential accidents they might have. And yeah, I'll go into a bit more of the specifics as we talk about the Oxford Formula Student car in particular. So scrutineering. There's a bit of context in the 2022 competition. I mentioned the lack of teams who got through scrutineering. Oxford entered their car for the first time. They managed to just about clear scrutineering. Unfortunately, just about too late to enter the main endurance race on the Sunday. So obviously a bit of a disappointment for the team, but I think in comparison to some other universities, it was their first time there, they did remarkably well. I think they got further through the scrutineering process than Oxford Brookes did down the road, who are an extremely established team. Part of that challenge is the electric vehicle side of things. So for the EV class, there is a mechanical scrutineering. It's essentially what you can imagine it is. It's the mechanical parts of the car, checking the suspension, the chassis compliance. And that's the same for all vehicles, whether you're in the combustion, or very similar if you're in the combustion class or the electrical class. EV vehicles obviously have to undergo 2 additional scrutineering. One is for the high voltage electrical systems, and one is specifically for the battery or accumulator in FS speak. And I think there's a bit of a misnomer in some circles about the concept of an electric vehicle. As mentioned, combustion vehicles typically use a motorbike engine, which is bought off the shelf. It arrives on a crate, and not to oversimplify it because it's still a big job, but you're effectively using something that is already in existence and known to work, and plugging your fuel and your air and your software maps into it to a certain extent. The batteries, certainly in our case, are custom designed by the students, and put together from scratch. Obviously, a battery can be quite an unsafe device, and so rightly so, the scrutineering process is extremely diligent on it. Oxford actually managed to get their battery through scrutineering, which I think was possibly one of the main points of failure of many teams this year, last year, I should say. I'm also aware of some universities who I think paid companies to design the battery for them and still didn't manage to pass scrutineering. So that's a bit of a credit to the students at Oxford who managed to do that. I've got a picture up here, so that's a tilt test they also have to undergo, which is obviously quite aggressive. Noise test, which actually in EV world it involves making sure you can make a ready to drive noise rather than too much noise from a combustion engine, and a rain test, so it's like a sprinkler, quite comprehensive sprinkler. More than a few cars go up in flames on the electric side. There's a few incidents at the last competition with that. And I've got a bit from Formula Students or Formula SE folklore here. This was a team in America. I think it was one of the Washington universities who back in the day designed their own 600cc V8 engine from scratch, which is no small undertaking. Pistons and all, developed their own combustion engine, and then were not allowed to take part in the competition, as I understand it, because they hadn't read the rule requiring a starter motor being on board of the engine. So it just goes to show how you can put all this work in, but scrutineering is such a massive part of the competition, and especially in first year Oxford University's main target was to complete scrutineering, which they didn't quite make, but optimistic this time around. So I want to talk about a bit about the layout. This is something that the students have put in place themselves, and this, I think, will be fairly, this is how Oxford have run their team, but it'd be fairly common to most universities. And indeed, if you look at this structure, very familiar to anyone from a motorsport or even general engineering background. So we've got myself as the faculty advisor. They have a team chief who is elected essentially from a series of interviews. It's currently a fourth year student, but at Oxford, all of the different years can get involved. These days, DPhil or PhD students can also get involved in the competition. We have one or two, but not many. It's primarily undergraduates and spread across first, second, third, and fourth years of the engineering degree. They've decided to split the team into a series of technical chiefs underneath that, so they have operations, technical chief mechanical, technical chief electrical, and technical chief for the race team, and then sub teams under that, each of which has a lead. So there's a lead chassis engineer, lead aerodynamics engineer, lead wheel assembly engineer, and in each of those areas they then recruit for students. It's open to the whole university, so students from anywhere in Oxford can get involved. Obviously, it's largely maybe 90–95% engineering students, but especially in the business and cost and marketing and sponsorship teams, we do have other people, and there's specific expertise from places like computer science and physics who have got involved. And actually, I think there's personally an action on me that there's a lot of expertise throughout Oxford, not just in engineering, who I think could bring a lot to the program, and so I'm keen to expand that. And the team all in, for all these people down from the team chief down to the members of each subsection, there's about 70 students involved. That involvement varies wildly, as it's an extracurricular activity from those who practically live in the laboratory and burn the midnight oil and commit significant chunks of their student life to it, to some people who do half an hour here or there, and it's all valuable work. Obviously, those who tend to commit to it will generally work their way up into a technical chief or team chief roles, and often, but not exclusively, have a real desire to go into automotive world off the back of it. But really, part of also the communication I think we're doing within Oxford is to get across that it naturally appeals to students who see a car and think, oh, that's I'm interested in Formula One, I'd like to get involved in that. But actually, it's just a great engineering challenge. You can see here we've got all sorts of engineering aspects to it, from the electrical to the controls to the the structures to there's options for people to get involved in AI in this, and so really broadening the appeal across Oxford engineering I think is key, and I'm trying to get out more and more that it's not just for people who have a dream of being in Formula One, although it will naturally appeal to those students. Slide hang up. Great. So I'm going to talk about Oxford University car in particular and a few of the quirks of it. Just as a bit of background again, I'd say this car was designed from scratch by students. It's really impressive given what they did with it, essentially with very little faculty support. I only joined last April, by which time this car was largely designed and in being made. In reflection, I think it's a learning experience for them, as the competition is meant to be, and so it's fair to say there's been an awful lot of learning that has come out of it. But in context, they've done a fantastic job. In the context of Formula Student, this is a fairly basic car by intent and design, and Oxford does not have the number of years of experience that a lot of other universities do to really build up and develop a sort of front-running car. Obviously, hopefully we'll do that as time goes on. The rules dictate that the chassis must be new each year, must be substantially changed each year. So that's by definition driving a new car. The reality for the students is, having just got through scrutineering last year, not quite having got as far as getting the car to run, their objective this year is to get the car through scrutineering and to complete all of the events in the competition. To that end, they are endeavouring to carry over as much as they possibly can from this car, OUR1, that's Oxford University Racing 1, into the car that's going to be competing this year, OUR2. And so while there's going to be a new chassis, a lot of the other parts are going to be carried over onto the car. So the rules dictate you can do various things. You sort of saw the little picture of Munich with a carbon fiber monocoque. For simplicity's sake, there's various good reasons for using a steel space frame, which is what Oxford has chosen and is pursuing at this time. It's a fairly simple contraption. Next year, they are changing it to include a little bit more space in it, to include some packaging constraints that I don't think they realized. With the chassis in particular, a big part of this is a packaging challenge. Capturing all the things that need to go inside the chassis accurately, I think, was one of the big learning experiences from them. One of the instances they had in scrutineering was, you can see these two black boxes on the back of the car, which are motor controllers and inverters for the electric motors, which need to sit inside the chassis surface envelope. So you can see that they're sort of popping out at the moment, and being able to package all of these things effectively at the planning stage is something I think they acknowledge needs to be improved on. In terms of safety, there's a thing called a structural equivalency spreadsheet they have to fill in, essentially comparing the values of the chassis to a known safe option. You've got to list things like your material selection is quite defined for the chassis for obvious safety reasons, and I mentioned the rollover area. It can be composites, and the students would love to put carbon fiber everywhere because they see it in Formula One, but again, in Formula Student world, it's not necessarily the most important thing. I know that I worked a little bit with Cardiff University students back in 2017, and they won the whole competition with a very simple space frame. So that's some inspiration for Oxford. Aerodynamics, likewise, this is a really interesting one. The students are particularly keen in aerodynamics. There are a lot of people who wish to study this, wish to push it further. Digging down a little deeper, I think it's because it's part of it is because of the again, I guess Formula One and motorsport connections, it's quite a visible aspect of it. It's talked about quite a lot on the television and so on and so forth. And so that seems to really permeate into the student's mind in terms of the things they need to put on the car. So there's quite an enthusiasm to put big wings and diffusers on the car and to just sort of mimic the Formula One counterparts. As mentioned, the Formula Student speeds, ultimate speeds, are quite low. So the sensitivity to aerodynamics is in quite a different place than it is in a Formula One car. And so there's been a bit of a re-evaluation, I think, on Oxford's part to focus on things that are maybe less sexy in aerodynamic terms, but equally important. And one of those is the cooling system. So I'll mention it again in a bit, but the battery and motors require cooling on the car. And I don't think any consideration was given to how much air might pass through this here radiator, which in turn cools the liquid, which the water which flows through the electric motors in the car. Which is all fine and dandy doing a big wing for the back of your car, but if it's going to overheat, it's not going to be great. Having said that, because of the enthusiasm at Oxford for studying aerodynamics, we have some very good students into that who've taken it upon themselves to find a composite sponsor and go forth and CFD some fantastic wings. So while it's not perhaps key in terms of performance for Formula students, in terms of a learning thing for students who wish to go down that route, I'm fully encouraging of it. But the Oxford car at the moment does not have a lot of aerodynamic principles on it. But hopefully that will change in future years. So powertrain is a really interesting one. The students started off with great plans to do a four-wheel drive car, which is permitted in the Formula Student rules. So some of the highest performing cars are electric vehicles. You get instant torque, which is great for the acceleration events and the relatively slow speed and relatively short endurance races. Formula Student really sort of lend itself to the electric vehicle side of things. To that end, they went ahead and bought 4 20 kilowatt electric motors with the plans to put them on the front and the back of the car. Then realized it was really quite a complicated problem to essentially get the electric motors working on the front wheels. The front wheels obviously have to turn with the car, and so that involves some complexities with mounting the motors on the wheels and so on and so forth. And so that was abandoned prior to my arrival at the team, and they're running 2 motors at the back. What that essentially means is that the car has half power because you have 20 kilowatt motors, 2 20 kilowatt motors rather than 4 20 kilowatt motors. In addition to this, there's been a clarification on Formula Student. They've changed the rules for this year so that the car can be 2-wheel drive, and you're allowed 80 kilowatts in that case of electric motor, or it can be 4-wheel drive, in which case you can have 60 kilowatts, which is less, which potentially drives it more towards having a 2-wheel drive vehicle. That means the students having to change the motors, the inverters, quite a lot of the high voltage system, which is a significant and expensive change for them to do. The car this year is effectively going to run half power because this is what they have available to them, and then in future I think they're going to have to significantly change the high voltage system in order to meet this. There's quite a lot of complexity to this. Obviously, you've got to get the power from the battery, regulate it, pass it through controllers to the motors. This includes things like the high voltage junction box. There's some rather large capacitors in there. They've got some off-the-shelf motor controllers, which are perhaps not optimally chosen. The motors they chose were from a company called Plettenberg, which isn't super. I think only one of the Formula Student teamers uses them, so they've not got a lot of reference to go off. But again, going into this blind a few years ago, the choices they made were for good reason, I guess, in their mind. But having learnt along the way, which is a massive part of this, they've definitely got a significant amount of improvement to make. As mentioned, very strict scrutineering on this, rightly so. So all those orange wire dictates the high voltage stuff. This is various pictures I'm showing you throughout this presentation of the car in the workshop in various states of build, but obviously before running, a lot of this has to be inspected and strapped and tied away, and be very careful over all of the routing of the cables and the water sealing and so on and so forth. Just a quick note, there's single planetary gear on the motors, so unlike a combustion engine, you don't have to run a full gearbox as a single gear ratio, which has been designed to attach to those motors. The electrics, so this is a really interesting one for us. I think, again, as mentioned, the car and the project seems to appeal to mechanical engineers at Oxford. We have an awful lot of people who are mechanically minded who are involved in it. and not enough electrically. Speaking to some of the other teams at the competition, this seems to be quite common. There were quite a few very nicely designed cars there that were lacking any sort of electronics on the car. And it's an interesting query as to why, because Oxford, the controls courses and electronics courses at Oxford are really popular at present, but there doesn't seem to be that filtration through from the controls and electronics side down to getting involved in the Formula Student program. To the extent where there are, for us, maybe 3 very competent students who've got involved in this over the years, which isn't really enough because, due to the amount of complexity in it. So to mention a few things, I've got a load of acronyms down there, which I know won't mean much to most of you, but includes things like the VCU, which is the Vehicle Control Unit, or you might know it as an ECU in a road car, for example. They've got to do a dashboard, there's a pedal box and a brake system plausibility device to check to cut the power if you happen to push the brake and accelerator at the same time, for example. TSAL, that's a tractive system active light, so flashes red or green if the electronic system is safe or not. BMS is a battery management system, so that's monitoring the temperature of all of the cells in the battery and checking that everything is as expected and feeding back. Emergency shutoffs all over the car. And there's some quite significant challenges in doing an electric car from this side. Particularly from Oxford, they made the decision to custom design all of their own electronics. So that means they have done from scratch their own VCU, their own vehicle control unit. All of the circuit boards have been custom designed by the students. All of the programming has been done from scratch by the students. Which is fairly uncommon, even in Formula One world. It's by regulation, the ECU is off the shelf, but I don't know of many motorsport companies who will go ahead and design their own ECU. It's quite a specialist thing, and indeed in Formula Students, a lot of the universities can buy a lot of this equipment off the shelf and implement these into the cars. So in a sense, it's a fantastic challenge that's been taken on by some of the students there, but unfortunately, it's also been their own undoing. The main issue we've had with the car has been electric, with coding, with wiring, with soldering, with all of the complexity that comes with doing this system from scratch and relying on a relatively small number of people in order to do it. So as part of the challenge I've taken on as faculty advisor is to really get more people, more electronics and more controls students interested in this and communicate that, whether you're interested in cars or not, it's a fantastic challenge and a fantastic thing to be involved in, and it really does some interesting controls aspects. Especially once you get into the performance side of things. So I mentioned virtual differential down there because the inside and outside wheels of the car will obviously have to turn at different speeds as you go around a corner, and traditionally combustion cars that's done mechanically, but as you can see, our system, which has 2 electric motors on the inside, that has to be done through control systems. Traction control, a lot of the performance can come through this. A lot of really interesting AI stuff can come through on that side. So there's a lot of opportunity, but currently not a lot of take up. And as I say, I think that passes across a lot of universities, not just ourselves. So it's interesting to understand that a little bit more. Wheel assembly. So this covers in Oxford World suspension, steering, braking. We've got fairly standard motorsport suspension that they've designed. I'll flip back so a couple of slides so you can see it a bit better on the full car side of things. You might notice a few extra bolts and corrections in there as they've underestimated the weight of their car and had to make some corrections to the suspension geometry and so on and so forth. I think it's also fair to say that Oxford University One probably has the turning circle of a London bus. It's not great, but that will be improved upon for OUR2. So definitely some learning in there. You might also, for those of you familiar with bits of car, have a look at this and think it's a fairly substantial set of uprights and brakes. This might possibly be able to stop that London bus as well. For reference, some universities can get away with, really light cars can get away with using mountain bike brakes these days on the car. So they're quite overbuilt, let's say. But on the positive, that's a great opportunity to save some weight for the next car. Battery, or accumulator in Formula Student speak. So again, this is really impressive. I think it's custom designed by students. Apologies, that's not the best picture I've got in there. It's essentially a rather large square box that fits. Let's see if we can see it in the space behind the driver. The best cars will often have relatively flat lying batteries tucked underneath the driver's seat to try and get the weight down low. But as mentioned, the fact that this battery passed scrutineering and was deemed legal is no small feat. It was done largely by a couple of DPhil or PhD students and the supervisor. Here, it's a very neat and tidy design. It runs about 10 kilowatt hours, which is oversized for Formula students, and most people tend to run about 7. It's based on lithium chemistry, pouch cells. It runs at system runs at about 114 volts, which is strategic in a way because Oxford defines high voltage as anything over 120, so it allows us to avoid some internal regulations, let's say, by running it at a relatively low voltage. The students have tried their very best to convince me it doesn't need any cooling and that it's going to last the whole event on thermal inertia alone. It's just going to heat up much like a kettle, but hopefully not trip over 60-degree temperature limits, which let's say we'll go and do some testing and check that out. So full safety and battery management system is built into the lid of this. As mentioned before, there's a lot of systems to check all the various module temperatures, currents, the voltages, a lot of safety systems to obviously shut the whole thing down if necessary. It's been very well designed, but it's oversized and it's fundamentally heavy. I think it's over 100 kilograms for the battery and the container that it's housed in, which is again a significant opportunity for weight saving in future. But frankly, I'd rather have a battery that's legal and gets them into the competition and is a bit heavy than vice versa. And I wanted to touch on marketing and sponsorships. So just talk a little bit about how Oxford runs this. So obviously, Oxford University is very well renowned as a premier university, but as mentioned, Formula Student for us isn't really that. It's quite new. Our annual budget this year is about £15,000 from the department. For context, I think doing a straw poll of student teams, something like 30 to 40 thousand pounds is probably more common for a lot of UK universities to put in. I'm aware that some of the big USA and German teams can run up to £100,000 or more, largely supported by sponsors. And so we really are operating on a shoestring budget. Obviously, part of that is the team is still establishing themselves. I think they need to prove that it can be successful for them and not detract from the course. Also, there's some realities around the cost of energy at the moment, and everyone's feeling the pinch, and so that includes us for sure. One significant benefit is we're given free workshop time. So there are a number of workshops throughout the Department of Engineering Science, and with staffed by fantastic technicians who don't charge for their time. Obviously, that's pushes us significantly towards trying to manufacture as many things as possible in-house. That's a really key learning thing for the students as well, in order to design things that can be in such a way that they can be made with our machines. So maybe you design something for a 3-axis CNC machine rather than a 4-axis CNC machine. That means we can make it in-house. That means it only costs the cost of the material. And so all of these things are feeding into their thought process at the moment. They are, as most teams, supplemented by sponsors, so we have an active marketing and sponsorship team. Obviously, this is a sort of thing where you build those relationships over the years. I've copied and pasted the current sponsors off the Formula Student Oxford website here. I'm not sure if this is up to date. I think a few have come and gone since then. Mostly this is in-kind support, so a lot of things like MathWorks will sponsor free licenses, for example. Bista Motion very kindly allow us testing facilities at their fantastic track down there for a very nominal price. 10 Tenants Motorsport is a small company who deal in fabrication, who are making the chassis for them. So in common with a lot of teams, it's sponsorship is a big part of it, but really obtaining benefits in kind for the most part. Getting cash sponsors is very difficult, and obviously some parts do need to be purchased. What we found is that a lot of companies are interested in it, yes, partly in the advertising available through the competition and so on, but also a lot to advertise themselves to Oxford graduates. So a particular emphasis on people getting involved with us who would like to promote themselves internally, to encourage people to apply for example, their graduate position. And so they're really sort of tailoring their marketing and sponsorship packs towards that side of things, which is interesting. And then just to finish off, a quick mention on future plans. So the objective for this year, second year, it's quite modest, but hopefully realistic, is just to compete and complete all the events. I say complete all the events, given the attrition rates, that's a significant challenge and not to be underestimated, but at least to make it through scrutineering and to make it into all the events and to do a solid job of the static events, take those seriously and do a good job of the cost and design events as the immediate goal. The regulation change is obviously forcing a bit of a rethink for the team, and so they're getting stuck into that at the moment. Starting to try and think more than a year ahead. They have a tendency to start thinking about the car design when they come back in October, which in a lot of ways is too late. Terms are very compressed at Oxford. Their time is precious, and so the earlier they can get started thinking about things, the better. At Oxford, part of my role is to integrate it a little bit more into the engineering science curriculum. So at the moment, or prior to my arrival, this is a purely extracurricular activity. But there are now third-year group projects and some fourth-year individual projects which are starting to get involved directly with the Formula Student program, which is really nice. It helps integrate the two and relieve some of the time pressures of some of the students when they can, rather than having to do a separate project and the Formula Student at the same time. For me, I think that it's a fantastic opportunity for the students who get involved, but also to really promote the Department of Engineering. It's fantastic to see at the open days when students come in, they see the car in the foyer. It's a fantastic thing. A lot of engineers really want to make something, get their hands on something. So it's really quite an inspiring thing, and I think Oxford can really use it to their advantage to promote it, promote the engineering science course. It's a fantastic thing you can get involved in. The courses are very theoretical, as they partly need to be, but really taking it to the next level and being apply some of those theoretical skills that they've learned is massive. And there are plenty of students out there who select their university based on whether they do Formula Student or not. So really do plan to use it for their advantage. Workshop move, so we're very compromised at the moment. It's making the best of what we've got in engineering science, but ultimately if the university's taking it seriously, which it is, we need to move workshop into a dedicated area with larger race bays, or I should say proper race bays and separate electrical working areas. So hopefully as part of a larger engineering science move, we're going to do that. And of course, we managed to beat Cambridge last year, so hopefully we'll do that again, which is always an objective for all Oxford University sports clubs. So that's my talk. Thank you very much for listening. I appreciate that's probably dipped in and out very quickly across some of the various topics, from quite a high level, but please do feel free to ask any questions and I will do my best to answer them. I can't promise to know everything about the car. Some of it still does evade me, but otherwise, thank you very much.
Thank you, Ryan. Yes, if you have any questions, can you put them in the chat, or if you particularly want to ask it in person, could you just raise your hand and we'll somebody is typing something. It was to say thank you.
All right, welcome.
I think if anyone has got a question, if you want to unmute yourself and ask it, that will be fine. How will electrical issues be resolved?
It's a good question. So the electrical issues have been resolved. The car does run now fundamentally, and they're planning to use exactly the same electronics for next year. So they're not in a bad place, having early March, and the powertrain systems on the car and all the controls work. I think in future we can't guarantee there are going to be people with sufficient skills to operate a custom design, fully custom electronic system. So probably they'll look to buying some things off the shelf which use common software such as MATLAB Simulink, so it makes it a bit easier for especially continuity as the students obviously move on and other students replace them. That handover of knowledge is key, and it's going to be very difficult when there's a lot of custom designed electrical. So that's part of it, but also a real push to get more electronics and controls engineers involved in Formula Student, and yeah, that partly falls on my shoulders to do it. So yeah, I'm optimistic, but it's definitely one of the main challenges they face.
Somebody else is typing. Whether it is a question or not is let's see.
Autonomous vehicle category, yes, absolutely. I'm very interested in this. Particularly at Oxford, there is some expertise, quite a lot of expertise into autonomous vehicles. We have an Oxford Robotics Institute, which is quite deep into that. It builds self-driving vehicles and so on and so forth, and some really phenomenal research going on in the area. My initial plan is to set up a small working team sort of feasibility study to have a look at it and analyze the best way to go about it. There are sort of two ways you can either use, as I understand it, apply your software to a default IMechE car, or use an existing Formula Student car that you've designed from previous years and apply the driverless technology to it. So in my mind, it's something that in a year or two we'll hopefully have a car, a spare car, if you like, which will be available to do that. And also, interestingly, the AI side of things is proving really popular with students. They're aware that that's something that's going to be moving on in industry, and they're really taking that on board, and those courses seem to be very popular. So I'm looking to really tap into that. So yes, is the short answer. I think it's a really interesting opportunity, and I've personally foresee it in Formula Student for us, not replacing the driver driven vehicles, but sort of supplementing it. I think it's a really nice combination. So we got in the bigger teams compared to your 70. Yes, it's really difficult to say. I think some teams definitely number over 100 students involved, but it's questionable as to how the level of involvement in it, let's say. So I say we've got 70 odd, but probably there are sort of 15, probably 20% of those do 80% of the work, I put it that way. Those who are really committed. And I think that seems to be largely true from my, admittedly not super extensive experience from all the universities, but I think that's quite common. Simulation techniques. Yeah, so this has been a really interesting one. So I myself come from a bit of a simulation background, where simulation drives your design, your sensitivities, and it defines your choices. When I arrived last year, the students had quite an active simulation team with a lot of members in it, who were doing some really interesting lap simulations that they put together. Really, quite impressive stuff. But had kind of gone off on their own and weren't talking to the rest of the team. There's a little lap time simulation competition as part of the submission, as part of the IMechE competition itself, and so they'd sort of gone off and were working on that and not really communicating back with the team themselves. And so it's a sort of ongoing thing to try and get that simulation to drive the design much more rather than being a sort of afterthought. And for me, that's really starting with OUR3. So not so much this year's car, but next year's car. Given that this year's car is essentially a carryover, to really sort of try and switch the thinking around to using the simulation to really use it to its advantages and use it to drive the design, and exactly as you ask in that question, to determine sensitivities and check different designs against each other, rather than it being sort of regarded as a separate simulation team. So yeah, it's been interesting to see how that's not been integrated, and I think the more they do with it, the more they understand that actually this is a really useful tool that we should be using. Yeah, so you can change the car's setup. Forgive me for haven't checked the rules on this super recently. Certainly, you can change the car's setup mechanically between events. There are some limits as to what you can do once you pass scrutineering. So obviously the car that has passed scrutineering has to go into the event itself. So if there's any, they can't remove anything from the car, let's say, or significantly change it, or change any of the safety devices for obvious reasons. But I do, for example, I've got one fourth year student looking at a bit of a theoretical project, which is a bit of getting the car to learn and identify which event it's doing, and sort of optimize itself for that automatically. So rather than having to set it up for a drag race event where you're caring mostly about traction and so on, at least from an electrical point of view, get the car to identify what it's lined up for and what it's done from a practice event, and learn from that, and feed that back into the control system. So there are some interesting things you can do with that, but also, yeah, some limitations. But forgive me, I have to double check the regulations on it as to exactly the bits and pieces that you can and can't change. I think it's fairly standard in terms of your mechanical setup and wing angles and so on and so forth. General basis for the rules. Yeah, so I mean, the rules are, it's obviously I'm personally not involved in writing the rules for Formula Student, and it's a massive undertaking, and I think they're trying to balance these things absolutely, safety and fairness. And for me, at least personally, I think they've got them they're pretty good. The variation in teams is really impressive, given that there are 154 pages of rules. So it's still really open, and you still see a lot of inventive stuff coming out. Naturally, to try and keep the safety up there, it has driven the cars towards certain sort of setup, and they've migrated towards system where you've got 4 wheels and a battery more or less in the same place, and a driver more or less in the same place, and so on and so forth. But there are still some really interesting ideas that come out of it. So there's a technical freedom there, but also, yeah, safety and the fairness. I think that comes into, for example, the 2 versus 4-wheel drive power thing that they've changed. That recognizes that it's really complicated to, or can be really complicated to implement 4-wheel drive systems. So doing a 2-wheel drive system and leveling the playing field that way, I think is part of the intention behind that rule, which is really good to see. So it's a really tough job writing the rules. I appreciate that. I think they've done a good job, and it's evolved over the years to incorporate those things you say.
Are there any more questions? If there are no more questions, then can I can I thank Ryan? I've been involved with Formula Student for many years as a business case judge, and to some extent I have seen things from the other side of the fence, on the organisation side, particularly in sort of changing the rules for the business case. But it's been fascinating to hear of all of the challenges and issues from a team itself. I've had some previous experience, but I think I've had much more of an insight this evening than I've had before. So thank you very much indeed. I'm sure we have all enjoyed the talk, and certainly the comments that are now coming up, everyone, and I wish you every success this year. And I can say that because I've retired as a judge. And while I'm hoping I might go along on the Saturday to see how things go, I don't have to stay neutral.
Fantastic. Thank you very much. And yeah, do pop by and say hello. And if anyone's got any further questions, you'll find me on the Engineering Science website. So, do feel free to get in touch and all that. But otherwise, thank you very much. Massively appreciated, and enjoy your evenings.